Photoelectron spectroscopy, or PES, this is a way to look at the amount of energy that it takes to strip an atom from its electrons. So we bombard the atom with photons, and then we measure the energy and the relative abundance of the electrons that come off. And from this, we can plot a graph. Now, the graph can, on the x-axis, can be normal or it can be backward. So you do have to pay attention to this. Also, because these graphs are so long, sometimes they're stacked up. So they cut them and they stack them up. So how the PES is important is that it proves electron configurations. So let's look at this first PES. So the first thing we need to make note of in the x-axis is where's our highest number on the x-axis and where's our lowest number. So on this, our lowest number is right here with 0, and our highest number is right here. And so we know that we are reading it normal. Okay, so where we count starting at 0 and then we count up. Notice that they've taken and they've cut it in half and then they've stacked it on top. All right, so what do we see here? So we see on the y-axis it says the relative number of electrons, and it actually does give us the number of electrons. So we have 2 electrons there, 2 there, and 4 there. All right, let's look at those electrons. Which ones were the hardest to remove? The hardest to remove are the ones that took the most energy to remove. These are the electrons that are closest to the nucleus. All right, so and as far as our electron configuration, these would be the 1s2 electrons. All right, let's look at which ones are the next hardest to remove. Well, these ones right here it says binding energy of 3.04. So I have 2 electrons there. Those are my next ones that come in my electron configurations, the next ones that are closest to the nucleus. And then last, I have these 4 electrons here. So in the electron configuration, it goes 1s2, 2s2, 2p, and then I need to look at how many I have, and I have 4 of them from the graph. So what is this element? So this element would be the one that has a 1s2, 2s2, 2p4 electron configuration. So this one would be oxygen. Oxygen has these 8 electrons. And so these 8 electrons are represented in the electron configuration. Again, the ones that are closest to the nucleus will take the most energy to remove. And so I know that I have 2 electrons there, and then I have 2 that are next hardest to remove, and then I have 4 that are the easiest to remove. And so those would be the 4 that come last. So again, 1s2, 2s2, 2p4, this is oxygen. All right, let's look at this one. So this one, again, we need to notice, are they counting normal or are they reversing it? I think my next example is one that's in reverse. So this one starts at 0, so this is counting normal, and then it goes to my highest, which would be 500. All right, so on that last one, I don't know if you noticed it, but we read it backward. So you always start from highest, and you go to lowest energy. Okay, so we have, looking at electron configuration, so 1s2, I would identify that peak as, and then the next one would be my 2s2 peak, and then the next one would be 2p6, and then after 2p6 I have 3s2, and then the very last one I would have 3p1 because I only have 1 electrons. Notice that the height of the peaks, they should relate to each other. So in other words, this one is a height of 6, so a height of 2 should be about 1/3 as tall. So if you're given, your starting peak should always be a 1s2 if as long as you have at least 2 electrons, and you can compare those 2 electrons to the heights of all the other ones. So you see that this one right here, that's directly below it also has 2 electrons. And you see that this peak right here is really, really tiny. So it's about half of that 2. So that would be 1 electron. What is this element? It's the element that ends in 3p1. And so this would be aluminum. All right, let's do 2 more PES diagrams. Oh, shoot. Let's do 2 more PES diagrams. Again, the first thing you want to notice is if they're counting it backwards or counting it normal, because you're always going to read it from highest to lowest energy. So starting off with this, there's 1,000 there, and on this end is a 0.1. So I know that I'm going to read it this way from highest to lowest energy, and I would list 1s2 as that first peak, 2s2, and then on this next peak, you can see that it's triple the one that's just before it. So this would be 2p6. And then I have a little peak here, and it's not quite 2 electrons. And notice on this side, they have labeled the 6 spaces. So 1, 2, 3, 4, 5, 6. Okay. And so that we can see that it's just a 1. So this would be an S1, this would be 3S1. So looking on the periodic table, you'd figure out what element it is. It is sodium. Let's do this last one here. So on this last one, I see that it starts with 250 and then it's going to 0 down here at the end. So I am going to read it this way, again from highest to lowest energy. I will label this first one 1s2. 2s2. We see this next peak, it looks triple, so 2p6. And then this next one is the height of the 1s2. So that would be 3s1. And then this next one, you can see that it looks about double the one that comes before it. So that looks like it ends in a 4. So a p4. So this would be a 3p4. So looking on the periodic table, we find that this is sulfur. So another way you can do this also is by counting electrons. I have 2 electrons plus 2 plus 6 plus, oh, I made a mistake. This is a 2 right there. Plus 2 plus 4. Okay, so you can add all those up and you'd find that you have 16 electrons. So this is sulfur. So I didn't mean to make that error. That is a 3s2 peak there.